Scott, can you hear me? This is Carl.
Okay. I heard it. Good. It got quiet.
Are we having fun yet? Okay, we got it. Thanks for your help, Jason. That was Jason.
I want to offer congratulations to Carl, our new president, and the other board members who stepped up and got elected to office at the last board meeting. Unfortunately, I could not attend it.
Well, we appreciate what you do, Mike. Really helps us out. Can anybody hear me right now?
Yes.
Okay. Is there anybody at the meeting in Auburn that can confirm that they're ready to go?
Gregor and NW7GO is signed in, and I think he's down there. He's doing the presentation today.
Mark, I can't get Como.
Yeah, we're all here.
Mark, I can't get Como to pop up on the
Okay.
FCC search. 3 a.m.
So this is Carl N7CJR, the president. I'd like to call the meeting to order. And if somebody present down in Auburn can do the Pledge of Allegiance, we'll wait for you to complete, and then who's ever giving the presentation can, or if David Okrent is there, go ahead and introduce the whoever's giving the presentation at this time.
Yeah, we got a pretty bad echo going here. Probably me. Yeah, that was probably me. All right. Let me see here. Okay. All right. All right. Thanks for letting me introduce the nanoVNA to you guys. And I wanted to thank Doug Wade, KK7PRS, for helping me write these slides. The next slide, there we go. So what is a nanoVNA? It's a small portable VNA, which is a vector network analyzer implementation. It's open source, open hardware. They cost around $50 to $150, depending on how big the screen is on them. Most of them work up to about 1 gigahertz to 1.5 gigahertz. Some will actually go up to 3 gigahertz. And you can kind of get them in two sizes, a small size, which is cheaper, and the bigger size, which is the more expensive, obviously. The one main difference between various models is how many points within the range that you're testing does it make measurements at. And those can vary from 101 points to 401 points. More points is better. Pros of the nanoVNA: it's lightweight, portable, battery operated. You can take it out in the field and do go, no-go testing. Pretty low cost compared to a real VNA. It does have 2 ports, so you can do more than just testing antennas. Cons: it's not as versatile as a real VNA. It's not very high precision. The chip used in it is really not designed for the frequencies that it does, and it does some tricks with harmonics to get around that. And to get the best behavior out of it, you have to be sure to calibrate it. Most models of nanoVNAs use SMA connectors, and they are just not meant for heavy use. They're just not really rated for high durability. If you drop it, you might break it. All right, so comparing it to a regular antenna analyzer like a Rig Expert, it does have the second port, as I mentioned before. So you can do things like testing coax. It can do multiple graph types, not just an SWR graph. It has much higher top frequency than normal antenna analyzers. Obviously, you can pay more to get higher frequency on the antenna analyzer. And again, it's not a rugged build. Okay, so nanoVNAs are not designed to handle any power input. Pretty much the only thing that the second port can handle is the output from the first port. So I would not put any kind of high gain amplifier on it. The connectors are fragile, and you should consider using connector savers on them. And again, let me say, it's inaccurate unless you calibrate it. Try not to use any connectors that aren't part of the tested system, because anything that you are using during your testing but not using when you actually use your system is going to decrease the accuracy. The nanoVNA, try to watch out for static electricity. Okay, so important thing to understand is that a vector network analyzer, and the nanoVNA in particular, measures a network. The whole thing. Your antenna, the cheap cable you scrounged, the dodgy choke you got at the swap meet, the bad ground connection due to corrosion, everything. But, you know, that's what your antenna is going to be using when you hook it to your radio too. So, you know, if it's bad for the nanoVNA, it'll be bad for your radio too. So you'll know anyway. So again, try to use the same set of things that you would hook your radio to, hook that to the nanoVNA, so you get a a good picture of what's going on. And my example here is if you have go out to your antenna and attach a little cable to it to test it, and then put a 100-foot coax back to your radio, they're not going to be the same when you get done with it. Okay, so nanoVNA has 2 ports. One is an output port and a receive port. So it outputs a signal and then it watches for reflected signal coming back to the port. And then it has a second port that will measure any signals that come to it. So for antennas, generally you'll only use the first port. For things like coax or small gain amplifiers and things like that, you'll use both ports. The nanoVNA, just like a regular VNA, uses S parameters. S stands for scattering. Doug made me put that in. They use a weird nomenclature where they say what port is it coming from and what port is it returning to. And so the first port in the nanoVNA is called S11 and the second one is called S21. And regular VNA may have ports S12 and S22, but the nanoVNA does not support those. Okay, frequency, the nanoVNA has pretty wide frequency, but as I mentioned earlier, it's doing some tricks to get that. So its dynamic range at higher frequencies is much lowered. Okay, controls on the actual box. Let me see here. Let me share the box. Okay, so the nanoVNA itself, let's see here. A little bit. So this particular one has a knob to control it. Some of them have knobs like this one. Some have buttons, and some have a sort of a jog dial that you can push to the right or left. And then it's also got on the side below the knob, I guess I can't really show it to you, it's got the input power charge and the power switch. Some nanoVNAs also have an SD card port so that you can copy measurements to an SD card. And some, such as this one, have an output USB port that you can use to power other devices. Not sure how useful that is in today's age. Okay, so the screen is small enough that tapping it with your finger just doesn't really work well. So you'll need a stylus or a guitar pick to control the screen. They come with one of those. Okay, so the menu is treed. You have to back out of a menu to go to another menu. And there's a back button at the bottom of each menu. The main menu has traces, stimulus, and markers. We won't talk too much about markers today. Traces, you tap on a trace and it'll show a check mark next to it, and then you can tap it again to turn it off. And then you can, for each trace, you can set what channel, what format. You want to measure SWR? Do you want to measure the magnitude of the signal? Some other things. And you can scale the output on the graph on the screen. The stimulus is where you'll set the frequency that you want to test. And again, markers allow you to get specific measurements at specific points by rotating the knob to put the marker at the point you're interested in. There's also a calibration, a recall to recall one of the saved calibrations, a config menu. Some of them have a storage menu to handle the SD card, and some of them have a measurement menu to do some specific things like TDR measurements of a coax link. The data points, the frequency range is divided into steps based on the number of data points. As I said before, the range is 101 to 401, depending on what model of nanoVNA you buy. The interesting inflection points can be missed if the range is too big for the number of points in use. So if you have something with a high Q where you might have a very tight point to some bandwidth that you're looking at, if your range is too wide, the points may miss that tight point. So try not to run the thing at the 50 kilohertz to 1.5 gigahertz range, because you'll miss all kinds of stuff. A clue is if the screen starts looking like polygons instead of smooth curves, you're probably measuring too many points. Okay, so calibration. I've said several times that it's important. The calibration happens in several steps. You let it measure an open port, you let it measure a shorted port, and then you let it measure a dummy load. And if you are going to use the second port, you also need to calibrate those with an isolation measurement and a through measurement. You can skip the second port calibrations if you're not going to use them. And they are called short, load, open, and through sometimes. So if you see that syntax, that's what's happening. Okay, so let me, at this point, do a calibration. I'm not sure how well you'll be able to hear me as I go over there, but we'll do our best. Let me just move this way. Okay. Okay, so tap on the screen. Oh, okay. Sorry about that. I'm going to also now want to open this. Let's see. So it may be hard to see on the screen here. So the connectors, are small SMA connectors. And there's an open one that has no pin in the middle. I am screwing it onto a UHF adapter. then I'm rerunning the open test there. Moving open connector from between. All right. Exactly so. Thanks for pointing that out. Doesn't take too long. Calibration, it's longer doing things on. Load calibration here. You can see this green spot in the middle. Kind of hard to see. That is on the Smith chart, and it is almost exactly in the center. So it's already pretty much calibrated. Recalibrate it. Okay. Now we have nothing on the second port, and I am going to put isolation calibration. And now I'm going to take a port table. Oh, yep, sure enough. And I'm going to click on done. All right. So now looking at the screen, we can see that the SWR, since we just have a small 2-foot loop connected, the SWR is right at the bottom. That's the light blue line. The SWR looks great. If only it was more than just a short piece of cable, that might be exciting. Okay. All right, so we set our stimulus range. I already had done that. We have traces, and those are all set up already right now. We have the S11 log mag, which is yellow. We have the S11 Smith, which is green, and the S11 SWR, which is blue. And I'm going to hook a little mag mount antenna to this. Okay. So, looks like on this camera, it's hard to see, but the line near the bottom is the SWR. And we are on the VHF range, and near the top, it's somewhere between 1.25 SWR and at 1.5 SWR, so let's call it maybe 1.35 or so. And down by 144 megahertz, it's below 1.25 SWR. So this antenna looks pretty good on VHF. So let me load a different config, and we'll see what it looks like on UHF. Okay, on UHF, it looks quite a bit different, and we can see that, let's see, this thing's going to up to 480 megahertz. And you can see that at about 460, the SWR takes off, and we have a really high peak at about 475. And well, I said we weren't going to do markers, but I will do it. So if we look at this SWR curve, which should be light blue, but it looks white on my screen here, I'm going to move that marker up to the peak to see where it is. Sure enough, near the top of the screen, you can see it says it's at 474 megahertz. So would not use this antenna for GMRS, but for the ham band, it looks fine. Okay, and now let's test coax. Now I have a 25-foot 8x coax, and I want to know how it's going to work on, again, UHF that we're currently on. So we plug that in. All right, so go back to the nanoVNA camera here. Okay, so now we have that 8x coax. You can see that we're definitely seeing varied SWRs, and this is just going through the coax with no antenna attached. So I don't think I would use this coax on UHF. See, definite problems with it up there. Down on HF, I'm sure it would read much better. So if we had a problem, for instance, let me detach the coax, like if the coax was broken. So now, the yellow line right near the top of the screen is showing that we have a very high reflection in the S11 log mag, it's yellow. And on the green Smith chart trace, we can see a characteristic of a disconnected line. I just disconnected the cable from port 2 to simulate that it was broken. So that's the kind of thing you would see if your coax is not working. That noise up there is the S21 log mag, and because we didn't calibrate for it, it looks terrible. If we calibrated with it on, it would have looked a lot clearer, and we could have seen what the loss was across the cable. But I forgot to put it in this mode before I calibrated it earlier, and I didn't want to take your time watching me calibrate it a second time. Okay, so Smith charts, entirely different subject. The far right is infinite ohms disconnected. The far left is 0 ohms shorted. And it's 50 ohms at the center. Above center is inductive reactance, below is capacitive reactance. As the frequency shifts, impedances often take a circular path on a Smith chart, which we just saw. And the distance from the center is the effective SWR. Parameters that the nanoVNA can show you. It shows you log mag, which is pretty much the standard measurement we want. It's in decibels. We can show phase changes. We can see delays from the original signal. Obviously, with the speed of light involved, we will see some delays going across the cable. It can show a Smith chart. It can show SWR. And it's got a lot of other things that it can show that are not as useful. Anyway, the nanoVNA, you can plug it into your computer to see bigger screen if you want. There's a program called NanoSaver. There's a couple other programs that also work with it, but NanoSaver is kind of the most used one. PC program. It can scan and collect readings. It can calibrate. It can show you up to 6 different charts at once, not all overlapped like on this. It only supports 101 data points though, but you can tell it to segment the reading. So it'll split up the range that you want to cover, do the 101 readings on the first segment, then the second segment, then however many segments you've told it. It also knows what the amateur bands are, so you can just say, I want to sweep 20 meters, and it'll just do it. And it doesn't have a tiny screen. Some nanoVNAs have it built in. NanoSaver also knows how to do it. It can measure the cable length. And you have to know the velocity in the cable that you're testing for that to work correctly. I had a note on this slide that it was not very accurate. And my friend Doug took exception with that. But, you know, it works for him, but it doesn't work for me. Even if I put in the right velocity factor, I get the wrong answer. So it could be just me, but it is available there, and it shows you at what time delay, you see the reflection. So it looks like it should work, but I haven't had any yet. Okay, so suggested links for further interest. There's lots of nanoVNA videos by W2AEW on YouTube. Lots by IMSci Guy, also on YouTube. On pure VNA issues, there's lots of videos by Rode and Schwartz. They have lots and lots of other radio videos. I definitely recommend them. And there's a book you can get off of Kindle called A Guide to the nanoVNA by Schwartz. All right, any further questions? Everybody's welcome to, at some point, come up here, maybe after the rest of the meeting happens, and play with the nanoVNA, and we can hook up various things.
Bill, Sam N7RHE.
Yes.
My friend Nelson, W7KBI, has a source, found a source for short 4-inch adapter cables, SMA to BNC female. And that works really good, and it's under $10 for the pair.
I'm sorry, I didn't hear the question.
This a statement for short jumper cables that go from SMA to BNC female that are about 4 inches long to save wear and tear on the small connectors. They're available for under $10 a pair.
Yeah, I'm using these UHF to SMA connectors off of Amazon. Other than they do the job, I can't really say anything fabulous about them.
Sam, I have a question.
Yes.
I have a nanoVNA, and I think it's the bear's knees. Is that right? Anyway, my vision and physical acuity isn't good enough to use the touchscreen on the nanoVNA, so I connect it to my laptop.
Right.
Suddenly, with the free software, I have a full screen to work with. Set all the menus, set all the options, and then do a test, and then do a comparison side-by-side test and show the difference. So it's a really powerful extension to the nanoVNA. I don't know if you were able to address that.
No, I don't have a nanoVNA, but my friend Nelson Swanheimer.
Yeah, I did mention the nanoVNA program that runs on the laptop.
Right.
I'm glad to, after the meeting, demo that for anybody that would like to see it.
It really makes a big difference. Sam, I'm sorry, Bill, I got you and Sam confused. I think it made a big difference for me, and the other people I showed it to says, well, that makes all the difference in the world. So it's
yeah, I agree. That is an excellent point. Thanks.
I got a connector question. It looks like if you have poor connectors, you could have some really bad results. Is that an issue that you found, or most of them okay?
Usually it's okay. I have had problems with bad connectors. We had a comment from David here at the meeting.
Well, that's why Nelson got the small 4-inch.
Yes, David is saying that he uses the nanoVNA to test balance when he's building them.
Right. But he uses those short cables to save wear and tear on the connectors on the actual nanoVNA. It makes it really good. His grandson also makes carrying cases for the nanoVNA, and then also holds the cables using a 3D printer.
We have a question here in the meeting. Yes, so yeah, so there's the original software that's open source, and then a guy named Hugin improved it, and that is the nanoVNA H. A different company, Deep Elect, has made their own version, and they have kind of two generations of that. The first generation is what's called the nanoVNA F. The nanoVNA F comes in an aluminum case instead of a plastic case, and then they upgraded it to a newer version that they call a deep VNA. So I have a nanoVNA F and a nanoVNA H over here. There's also an H4 that. Yeah, I think the H ones are a little more featureful, and the F and the VNA are more robust. I've also seen ones that have the executive construction instead of FNA. I don't know if they another question. Well, it's open.
Bill, please repeat the question and make your statements directly into the microphone for the benefit of those on the internet.
Bill, you're not coming over the Zoom call at all.
We had you there for a second, Gregor. Gregor, when you were messing around with the cable on the end of that microphone, we could hear it, but when you let loose of it, there went the audio.
Testing.
Sounds like a helicopter.
All right, are we back on the air? All right.
We can hear you now.
All right, the last question was really a comment that there are a lot of copies of the nanoVNA. The word counterfeit is maybe not inaccurate, but since it's open source, they're allowed to. But anyway, so be careful not to buy cheap copies. Any other questions? All right, well, thanks very much, everybody.
Gregor, I do have one question for you before you wrap up. I must be too late.
Oh, say that again, Robert?
I've got one question about your nano box on camera when you had it on there. Because it says deep VNA. Is there a different version that is not in quotation a deep VNA?
Absolutely, there is. There's a nanoVNA, which I know is the one you have. There's a nanoVNA F. There's a nanoVNA with no appended letters. And they're all very similar. The nanoVNA H, I think that's the best.
All right, got it. Perfect.
This is Carl N7CJR. Thanks, Gregor, for that presentation. And I think we should probably take a 10-minute till 11 o'clock. Does that sound good for everybody?
Yes, we're taking a 10-minute break. Be back in 10, and we're ready for the rest of the meeting.